Today we're tackling a problem that seems simple, counting equivalent domino pairs. But the naive approach quickly becomes inefficient. Can you find a way to count these pairs much faster? You're given a list of dominoes, where each domino is represented as a pair of integers. Two dominoes are equivalent if they have the same numbers, regardless of order. For example, 1 2 is equivalent to 2 1. Your task is to return the total number of equivalent pairs. Remember, each pair of equivalent dominoes only counts once. The most straightforward approach is brute force. We can iterate through every domino and then, for each one, iterate through all subsequent dominoes to check for equivalence. This involves nested loops, comparing each domino with every other domino. While it's easy to implement, this leads to a time complexity of O(n squared) because of the pairwise comparisons. For larger inputs, this quickly becomes too slow. We're doing a lot of redundant work, repeatedly checking pairs we've already considered or could process more efficiently. The key insight to optimize this is realizing that equivalent dominoes should map to the same canonical representation. We can enforce this by always storing the smaller number first. For example, both 1 2 and 2 1 become 1 2. We then combine these two numbers into a single integer key for a hash map. A simple way is to multiply the first number by 10 and add the second. For each domino, we calculate its canonical key. We then check our hash map. If this key already exists, it means we've seen this type of domino before. If its frequency is x, then the current domino forms x new pairs with the previously seen x dominoes. We add x to our total count, and then increment the frequency for this key in our map. Let's trace this with an example. 1 2 2 1 3 4 5 6. We start with an empty map and a count of 0. First 1 2. Its canonical key is 12. It's not in the map, so we add it with a frequency of 1. Next 2 1. Its canonical key is also 12. This key is in the map with a frequency of 1. So we add 1 to our total count, making it 1. And update the map's frequency for 12 to 2. Moving to 3 4 key 34. Not in map, add it with frequency 1. Finally, 5 6 key 56. Not in map, add with frequency 1. We've processed all dominoes. The final count is 1. This is correct because only the 1 2 and 2 1 dominoes form an equivalent pair. The HashMap approach correctly identified and counted this single pair. You'll spot this pattern when you need to count pairs or groups of items that are equivalent under some transformation, like order-agnostic comparisons. Anytime you can normalize items into a canonical form, and then need to count occurrences or combinations, consider using a hash map with that canonical form as the key. This optimized solution achieves linear time complexity, big O of n, because each domino is processed once. The space complexity is big O of 1, constant time because the number of unique domino types is constant. Mastering canonical representation and hash maps is crucial for many counting problems. Try the next problem using this same pattern. Don't forget to like and subscribe for more efficient algorithm breakdowns.